Using the Flir C2 here, measuring the temperature of a uniformity of a heating element out of a heat shoe. And I can go over here and move the look to see this is all about the same color along here. This particular model of C2 will go up to 150 degrees C or 302 F. And once you get above that, there's a little star that appears here. So you need to use a higher end model. But this element here I've been running is a couple times gone through and run where one side's hotter than the other, which doesn't make any sense because it's just got two wires on each end. So my theory is it's probably shorting out on the frame over here, which is an extrusion. This is an extrusion, and this is the piece that goes on, and the heating element goes between two pieces of mica here. So right now we're just setting this up by itself, running in free space, and we're just looking to see if there's any hot spots or any place there's a short. There's an area here that's a little bit hotter. This is a 240 volt 1800 watt coil, and I'm running it on about, say, 85 volts AC, and there's no aluminum, so it's going through and just running in free air on some bricks here. So I'm going to cool this back down and run it on in the actual extrusion piece. Those two lights there are in series, 120 volt bulbs, just so I get some feedback what's going on here for the brightness. Here's the thermal probe. I think that's a negative temperature coefficient thermistor. Maybe. It's got red and white wires here. It's about 5.9 ohms a minute ago, and I've got it. It may be positive. Heat it up here. It's getting a higher resistance the hotter it gets. Turn the camera on here. And these hard to tell what I'm looking at. I think it's about 90 degrees. About 9 ohms, 8 to 9 ohms. So the hotter it gets, the higher the resistance. Here's the mica. It's on either side of the nichrome strip. And then here's the extrusion it goes into. And then this T section here is jammed up into there. That's inserted in the piece like that. Okay, here's the bottom mica. Here's a heater strip that you center, and here's the other piece of mica. I purposely moved this out just to show the sandwich. This extrusion tee goes on top, and then these are the set screws that are in pairs that clamp this down so it's in compression. There is on this a little bit of undercut here, and that's for the bump of the connection here. Okay, there I'm sliding this extrusion in. I had to back off some of the set screws, but this pulls in right in here. Once it's all into place, I'm going to lock the set screws down. Just pull that in place. So you can pull this over. I'm going to have to back some of these set screws back out again. But there's the back end of the heat shoe. This is the heat, keeps the heat around the roller is what it does. The roller for laminating one is right inside here. There it is. A sandwich of mica, heating element with mica around it, plus mica. And we're going to see if we can heat this up and see what happens. There's the Allen key to tighten these little set screws up. Not sure, I'm not going to make this super tight because the place who made this is out of business, plus the place who made the heater, Frost Electric, they're out of business too. Both in Southern California, so I'm just going to snug that down a little bit and we're going to fire this up and see what happens. Okay, there's the heat shoe plus the heat shield around here. Got it connected up to one wire here, the other wire. Get this on some bricks here, pretty stable. We can go ahead and fire this up. Probably get some smoke coming off this when we first turn this on. Plug it in. Just put 80 volts, about roughly 80. That's a setting of 80, which this old variac here, that's the voltage out if it had 115 volts in. This is going to take a while to heat up, so I'm going to crank this thing up to 130 here. I don't have a 220 volt variac handy or a 220 volt source here, so we're going to go ahead and just run this on 110. Should be quarter the power, but this thing doesn't take gobs of power when it's fully warmed up. I just want to see if this has got uniform temperature across it when it's warmed up. Because what was happening here is it was hot on one side here, say 280, and over here was only 230 after it ran for many minutes, which is really strange. Like the heater is somehow shorting out and only one part of the coil is using. So when I took it apart, all the mica looked fairly good, so I'm kind of baffled what the heck's going on. I called the factory years ago about it. They said they almost never replace the elements, and so if it's the temperature control, all this has got is one sensor, and so it's closing the loop around right in here, on and off, or pulse width modulated or something, and all it has is two elements. So my first thoughts was that it's probably that the element is shorting out, so only one part of this was working. This is getting a little bit warm. Okay, it's been about 4 or 5 minutes. We're up to 10 ohms across the thermistor. Here's the Flir showing that the lighter colored piece of anodization that goes under the roller is at 148 and the black one is only at 100, which kind of surprised me because the heater's on either side, and out of its, they look like they got almost the same piece of thermal mass. The black should radiate more than the lighter colored. The heat shoe here itself, where the film goes across, is only about 102, and then the bottom piece that surrounds the roller is already up to roughly around 160. And maybe I'm wrong. Maybe the mass of the black piece is 3 times more. They're both, that's anodized aluminum, but it's amazing. There's a different, way different temperature difference on those. So I'm going to let this run for a while, see what happens. Over here in the thermistor, we're up to 11 ohms, and that's the probe that's up in there that comes with the stock laminator. Okay, it's probably been about 15 minutes. This is 25.5 ohms, say. Get about 136 volts across the coil. Looks like the black part of the sensor, the heat shoe's roughly around 230. $241, 236. It's fairly uniform, in the sense that I don't have it, it's not like it's shorted out yet. So I'm going to turn off the flare, go through, take a piece of lamination film and fold it over on itself. You just put it over here on the shoe, and you can see that I've got the sticky side to the sticky side, in the sense the part with the adhesive on it, and I really need 3 hands here to pull on this. When it's pulled across the shoe here, the heat's up on the roller. Pull this like this. And it turns clear. Now that part is stuck to itself. I'm going to turn this off and do it again. Okay, there's the shoe. Getting up there in the heat. Take some lamination film. Usually the shiny side touches the shoes. So I'm going to put the non-shiny sides together just to show how it bonds. So when it's pulling across the machine, it's going like this. This may not be hot enough yet. And that's how it turns clear. There's a shoe on the top and the bottom. Now if I try to pull this apart, if it's not hot enough, it's not going to stick, but that's actually fairly well bonded. So if you actually take a piece of film, you're going to burn. This is like a hot stove. You put it on there, it's a sense that you... So when the machine's running, you've got the shiny side here is toward the shoe, and on the other shoe, and so the 2 frosted sides are coming together through the rollers, and the paper's embedded in that. I'm just showing what happens as though, like you had an area there wasn't any paper. So the faster you run the machine through here, the more heat's going to be pulled off the shoe. So the speed control on this, when you speed it up quicker, you need more power wattage into it. This particular machine is 220. It's got 2 1800 watt coils. So that's 3600 watts. It's up there. Okay, I've got just the one shoe there. Got a piece of lamination film, and I put a piece of inkjet the customer had. see if this actually... Of course, I can't pull this like a set of rollers. It'd be nice and smooth. There it is, about 27 ohms. Over here in the coil, heat shoes around 254. It's really nice and uniform. That's normally what this thing runs around. I run it around 250, 260. It all depends on the film you've got in it. So it's all nice and uniform, which is kind of baffling, because this is the one that, when it's screwed up, this one side has been 280, the other one's been like 220. Way cooler. Like the heating element is shorted out internally in there. This is the one the factory didn't know what it was, nor the heater maker. It's kind of scary. It's really nice and uniform. So we're going to cool this down and actually stick this in the laminator. Okay, got 149.7 volts across the coil because I've got this variac feeding into this variac. So they're 5 amp variacs, but what I've got is I've got this pumping a little bit more into this one. This is at full tilt, which is kind of screwball. It's not going to pop the circuit breaker on it because that's a 5 amp device. There's a little bit of margin on these because they're 50-60 hertz. Not saturating the coils. Get this a little bit hotter, see what's going on. Here's the heat shoe in place. There's the roller, the top roller and the bottom roller. The film goes through. There's 2 rollers that go through there, and you adjust the pressure between the two. The shoe just sits on here. This is the one wire for one end of the coil. This is the thermistor, and here's the 2 solid state temperature controls. So what's been happening on this is one side of the heat shoe will run, it'll all be uniform, and after it's up temperature, maybe after running it for a half hour, it may go for weeks. This one side will be hot, the other side will be completely like 80 degrees cooler, which doesn't make any sense. So since it's only got one wire on there, on either end, the same coil, my thought is it's been shorting out intermittently halfway through here, or a short to the frame. So we're going to run this thing independently with off a variac just to see what's going on. Okay, got the heat shoe in there, got it hooked up to the temperature controllers, and then I've got my lights across there that have 210 volt bulbs in series. So if I turn up the control here, they come on. So this is a bang control in the sense that it puts 240 volts across the coil. I know that because both bulbs are sitting there burning 120 volts across each one. Those bulbs are in series. Here's the other wire here. Kind of dangerous. But trying to figure out what's going on here. So the control on this is just if I move the knob back and forth around a set point. It's just basically turning the heater on and off. It's not running it like a pulse width modulating at the duty cycle. If it did so, the bulbs would be appear to be half brightness or something like that. It's just turning it on and off. Simple temperature control. Feedback here is the thermistor, which goes from something like 15 ohms to like 27, 28 ohms when it's hot. I showed earlier. That is the control for the top shoe. This is the bottom shoe. And this is the one that's had the issue, so I'm going to turn this up to its 240, see what happens. I took the knob off and didn't really mark it, but I noticed where the little mark was on the shaft. I didn't have to take the knobs off. I shouldn't have done this to pull the sides off. So I put it back pretty much where I thought because I could see a little indentation on there. And we're setting this to 240, and we're going to look at this with the temperature probe. And once it gets up to the melting point, this will turn from frosted to clear. And on this particular machine, when you really want to run some laminate, what you do is you have the roller slightly revolving at the slowest speed, kind of like a rotisserie, and what that does, it gets the heat even on the roller down there, because this is not a heated roller machine. So I keep the roller going a little bit. I'm going to turn the bottom heater on too. That says 46. I turn that. What I could have done as a test is I could have gone through and swapped. If I assumed one of these controllers was bad, I could just go ahead and use the top unit to drive the bottom, or vice versa. This is about a laminator from about 20 years ago. So I'm going to set both of these to around 250. You can see on here that the lamination film is just starting to melt. That's 220 on there. You need to run it hotter than that because you've got to have some margin when you're pulling the film through there. Now when I've got the roller running through here, I have to have this unclutched, or you'll start to speed out your waste lamination film. This is a model BA PS31, which is a 31-inch, 230 volts, 18 amps. It's only 18 amps when you've got both heaters on right now, full bore. And once you're up to temperature, it's going to cycle on and off, so the current's probably half. If you run some really thick lamination, it'll have a higher duty cycle. Running a test sample through, see if we got good bonding. Just because this is good to itself doesn't mean it's good to the paper, so I'm going to purposely cut through the paper, see if this has got a decent bond to itself. It can be marginal to where it'll bond to itself. The adhesive's on the inside here, and these are both set to about 280. Turn off the machine drive. Open this up. Turn the machine drive back on. Keep the roller warm. I'm going to cut that out of there. Through here. See, it didn't bond. That can happen sometimes with inkjet too. There's a coating on there. So it bonded to itself, but not the paper. $258, $277. So it's a little bit hotter on this end than before. Okay, the stuff I'm running through here, this is some very cheap lamination film, school grade, that the melting temperature is around 260, and then when you got a thick original like this inkjet, I've got this thing running around 290 to 300 degrees up here because it's not to get it to bond well. Normally I run the fans and everything, but this is just what happens when you get inkjet material. It's got like a surface, like it's got crap on it. Feels like it's got powder. I'm just running it really slow so it'll have a decent chance of being bonded here. Normally I'll run this thing 10 times as fast, but there the heater just came on. This is just some cheap film that it's got to run really hot because it's a bunch of junk basically. So here I'm out of the range of the thing. It's supposed to go to 302. That says 320F, 312. This old Radio Shack one says 311 here, 321, so it's fairly close. This is incredibly slow. Normally I don't run something this slow, but this film is some surplus film that is made overseas. It's got really bad adhesive, and since it's cheap, what happens is the bonding temperature is around 240, 250, and I'm running this around 300 because the material in this inkjet just doesn't want to bond very well. Regular paper will run through there okay, but some of the inkjets don't really like to bond well. Should go ahead and break down. Next roll I'm going to get a better quality roll. Again, just because this is bonded together like this doesn't mean it's bonded on the paper. Like on here, if I went through and just doesn't like to bond. Got some wrinkles in here through a little bit. It's very humid here, so the materials get moisture on it and they heat up and tend to expand. If I would have printed this, I would have printed on thick paper, but this is for somebody else. They end up using really cheap paper. It's got a little bit of coating on it, but it's really horrible for laminating. Doesn't really work very well.